Collision theory and the rate of reaction. Okay. So for the reaction to happen from A to B, we have activation energy. What is the activation energy? Is energy required for your reactant to collide to each other. You need to have to be energetic enough. When they collide, they combine, right? That's why you need to give them some boost in terms of energy. This activation energy is the energy that need to react with each other. So here is the reactant here from the reactant to this top is activation energy. At the top, we have activated complex. We have something is forming here. We call them activated complex. And then here is product. Of course, the energy difference between product and the reactant will give you the net potential energy change delta H. Here, that was for endothermic. Here is for exothermic. Again, you have activated complex and activated energy. Here is a net potential energy, as you see there. So you can do question number 1 as a practice. Now, reaction mechanism. Some of the reaction that is happening, it's not going to happen in a single step. It could happen in the multiple step. For example, this one, HBr, for HBr plus oxygen, give you 2H2O and 2Br2. So experimentally, the rate of reaction for that is KHBrO2. See, we have HBr and O, so it depends on that. And the power of each, that is 1. But actually, we see this mechanism as happening. HBr plus oxygen give you HOOBr, and this HOOBr will immediately react with HBr, another HBr to form H to HOBr, and this HOBr again will be immediately consumed by another reaction. So this HOBr that is formed and then consumed again, same as HOBr, formed and then consumed again, we call it reaction intermediates. As you see, the first one is a slow and these two are fast. Means the rate determining a step is the slow one, because the fast one is not going to affect the rate of reaction. Just the slow will tell you how long the reaction is taking or how fast your reaction is taking is by that one. So it's the rate determining steps. When you add everything, these 3 steps, you of course get the target ones. Also just pay attention, the slow when it is rate determining. Look at the coefficient of the HBr. The coefficient of HBr is 1, the coefficient of the O2 is 1. That's why the power here for HBr is 1, the power here for oxygen is 1. So you need to look at the rate determining reaction to come up with the order of this rate. Okay, this is telling you the steps. So HBr plus O2, this is the first activated one. That is, this one is HOOBr is forming here. And then this will be consumed. And HOBr again form here. And then HOBr reacting, and you have a H2O and Br2 at the end. So look at this question. Consider the composition of the dinitrogen pentoxide 2N2O5 give you 2N2O4 plus O2. What would be rate equation if the reaction occurred in a single step? If this is only things happening, so this is rate determining. The coefficient will be the power of, when you write the rate law, so it's Kn2O5 the power of something. this is the only step. So this is rate determining, so the coefficient will be there. But the actual experimentally, we derive that to be this. That's why the rate determining steps not gonna be the above one, right? It's gonna be 1 and 205, give you some product. Now we wanna suggest some possible mechanism. So some possible mechanism is that you start with N2O5, give you N2O4 plus oxygen. Take one oxygen is there. And it's gonna be a slope because this is rate determining because the coefficient is 1, we got this one. It's gonna be a slow one. In next step, N2O5, you have oxygen, and again, one of the oxygen go out and it will give you O2 and N2O4. Make sure you have N2O4 here, 2 of them. When you add them, you have this. We'll get the target. It's gonna be fast, it's gonna be slow because this is only depends on N2O5 here. Here is another question. Consider or reaction involving 3 elements as reactant and comes as this. So you do the experiment and you see doubling the concentration of the X has no effect on overall rate. Means X have no effect. Means concentration of the X should be 12 0. Doubling concentration of the Y, the overall rate become 4 times bigger. If doubling become 4 times, it means the power was 2 because 2 to the power of 2 is 4. Doubling the concentration of the double the overall means the power is 1 because 2 to the power of 1 is 2. So by doubling this, it will double your, and this is overall rate of reaction, rate law, R is called K because there's a Y power 2 Z to the power of 1. So it means this is the rate determining step. It's going to be 2Y, 1Z, sum product. Now you want to do some suggestion for mechanism. Maybe I just write down again, the X plus 2Y plus 2Z equal to, okay, this give you X, Y2, Z2. Okay, now this is the rate determining. Okay, since we know that the rate determining is what, 2Y plus 1Z, right? So we have that one for sure, 2Y plus Z. Give you what? It give you Y2. Y2Z. Since you don't have Y2Z in this final one, of course, you need to have another one. Make sure you consume that. 2YZ plus what? Because you need to eventually produce this, right? Y2 and Z, you have another X and Z. You need X and Z here, right? And they combine, give you X, Y2, Z2. But this is there, but you don't have it in the final, so you need to make sure this is going to be produced somewhere. And here is the place it's consumed. So having that means you have X plus Z to give you X Z, right? If you add them up, you have 2Z here. You have 2Y. You have X, and you have Z. But this cancel with that, this cancel with that. So you get that part. And of course, this gone, this gone. So the intermediates are X to Z and Y to Z. So you can try doing this question for practice. And also this question number 3 on this page.